Okay, so I'm going to go over the notes on carbohydrates, or sorry, on the carbon cycle here. All right. So essentially, you guys have seen examples of cycles before, things like the water cycle, the rock cycle before. Well, another cycle that you're going to have to get familiar with is what's called the carbon cycle. All right. The carbon cycle is a cycle where carbon, that goes right here, carbon compounds are interconverted between atmospheric forms. Atmospheric is ATMOSPHERIC. All right, and what atmospheric basically means is in the air. All right, atmospheric forms. All right, and trapped land-based forms. All right, so what is the form of carbon when it's in its atmospheric form? All right, so the major form of carbon in the atmosphere is going to be in carbon dioxide. All right, so you can write carbon dioxide right here. And when people talk about carbon dioxide, sometimes they use its chemical formula, and that's going to be CO2. All right, that's capital C, capital O, and then a number 2, but that's kind of down and to the right side. All right, hopefully you've seen it written that way. All right, so this is a little bit oversimplified of a drawing right here, but we're going to try to go over the basics of the carbon cycle right here. So first of all, we have a large amount of carbon in the atmosphere. All right, and so what's that form? It's going to be in the form of carbon dioxide. All right, a lot of you guys know carbon dioxide because it's the gas that you breathe out every time you take a breath. We take oxygen in, we breathe carbon dioxide out. All right, so right here you're going to want to put CO2, and also you might want to write carbon dioxide. It's just the same thing. All right, so the thing is, we as humans and animals need carbon in order to live. All right. Our muscles are made of carbon. Every human has fats, and we have sugars in our body that we need to live. All of these are made of primarily as carbon atoms. All right. So can we get those carbon atoms directly from the air in that from that carbon dioxide? And the answer is no. There's only one thing that can directly get that carbon from the air, and that is green plants. All right. Green plants are special because they can do this little process called photosynthesis. All right. So in this little box right here, you're going to want to write green plants capture CO2 from the air through photosynthesis. All right, and photosynthesis is PHOTOSYNTHSIS. All right. Um, so, so in the process of photosynthesis, you're also going to want to write this one little basic reaction: CO2, and then draw an arrow to the right, and then write carbohydrates. All right, and what that shows is that essentially photosynthesis turns carbon dioxide in the air into carbohydrates. All right, and carbohydrates are just a term for things like sugar. All right, so that's what the plants do. All right, so the plants do the job of taking the carbon from the air, making carbohydrates through photosynthesis. So then how do we get them? All right, well, obviously we can eat plants. All right, so here it doesn't show humans, it actually shows a cow, but just like a cow can eat grass, we can eat things like corn, things that come from plants. All right, and when we do that, we are taking those carbohydrates into our body. So you can write down here, animals get carbohydrates from the plants. All right, so and you might just want to draw an arrow from the tree or the grass to the animal. All right, actually, I think that's what this is showing: grass going to the cow. All right. Well, one thing that this doesn't show is that we don't necessarily we can also just eat the animal that is eating the plant. So that's how we get our carbohydrate. All right. So so that's how the carbohydrate gets to the animal. All right. So how about some processes from the land-based forms turning carbon back into the atmospheric form? All right. So right now, each one of you guys has got sugar in your bloodstream. All right. And you can burn that sugar. All right. And that process is called respiration. All right. And respiration is when humans or animals turn carbohydrates into carbon dioxide. All right. So if you were to feel your arm, you can feel that your arm is warm. That's because your body is burning that sugar. And one of the things that happens when you burn that sugar is that it creates carbon dioxide, and your body gets rid of that because every time you take a breath, you breathe that carbon dioxide out. All right. So again, respiration is and that's when carbohydrates turned into CO2. All right. So another way that carbon gets returned to the atmosphere is through burning. All right. And so right up here, you can say burning fuel. All right. There's two types of fuel that we could put here. We could put wood. All right. Everyone should be familiar with burning wood in a fireplace. But another common thing that we burn is gasoline. All right, so burning wood or gasoline, all right, and that's going to release carbon dioxide into the atmosphere. So one other common way that carbon gets returned to the atmosphere would be whenever a plant or animal dies. All right, let's say they actually try to show it right here with this dead bird. So picture this dead bird as being over here. All right, so dead plants and animals will eventually decompose, and when things decompose, the carbon in their body is going to get turned into carbon dioxide. So that's another way that carbon can get returned to the atmosphere. All right, one thing that's not shown in this diagram right here is something that sometimes happens to dead plants and animals. All right, every once in a while, dead plants and animals will get buried. All right, and then more dirt will get on top of that, and more dirt gets on top of that, and that thing that's originally buried gets covered deep underground, and essentially that's how coal and oil get formed. All right, so when someone goes and digs up coal from a coal mine, they're essentially digging up prehistoric plants that got buried by dirt a long time ago, and over millions of years got turned into coal or oil that's underground. All right. So some of that carbon that gets trapped from the atmosphere by plants eventually gets buried. All right. So can that carbon eventually make its way back up to the air? Yeah. In prehistoric times, that stuff would stay buried, but I think most people know that humans have figured out that if we dig that stuff up out of the ground, we can burn it, and in the process of burning that carbon dioxide is going to go back into the atmosphere. All right, so there's a little bit here that I have in the notes that I just want to hold up so that you can see it. All right, and that is, let me see if I can get this centered right here. All right, that is going to be some basic chemical reactions that are involved whenever you have photosynthesis. All right, so the chemical reaction for photosynthesis, which I'm going to call carbon capture because we're taking carbon out of the air and we're capturing it in the form of sugars, which are on the ground, all right, is going to be CO2 plus H2O yields C6H12O6 plus O2, all right. So that C6H12O6, that's commonly referred to as sugar. All right. So there are some also, so essentially carbon release reactions are the opposite of that. All right. So if we took this reaction right here and we turned it around, you could take sugar, all right, and you could combine it with oxygen, which is O2, and that's going to make carbon dioxide and water. All right. So the three carbon release reactions are going to be decomposition, respiration, and combustion. All right, essentially decomposition is when a dead body decomposes. Respiration is essentially us breathing, and combustion is whenever you burn something. But any of those are going to involve sugar type molecules combining with oxygen. All right, where do we get our oxygen for respiration? We breathe it in with every breath. All right, and then it's going to create carbon dioxide, and y'all should know we get rid of that every time we breathe out. All right, but one other thing that gets formed is water. All right, so I want to show over here that little part on that little area right there is to show those prehistoric dead plants and animals that got buried and eventually became coal. So the thing is, as long as we are taking carbon dioxide out of the atmosphere through photosynthesis just as fast as we're putting it back into the atmosphere through either breathing or from burning things, there's no big deal. All right, we would keep the same amount of carbon dioxide in the atmosphere. The problem is that we're creating much more carbon dioxide in the atmosphere a lot faster than we're capturing it through photosynthesis. All right, so in this part right here, we're sending carbon dioxide into the atmosphere much faster than plants can absorb it. All right, and the main reason for that is because we're digging up a lot of that coal and oil, which used to stay buried underground, and we're burning that. All right, and all that carbon has now got to go somewhere, and it goes into the atmosphere as carbon dioxide, and plants just simply can't absorb it as fast as we are putting it into the atmosphere by doing things like burning gasoline in our vehicles. All right, so the problem with carbon dioxide is that it therefore builds up in the atmosphere. All right, and carbon dioxide is what's called a greenhouse gas. All right, which means that it absorbs a lot of heat that would normally escape into space. All right, and because it doesn't escape into space as well, it ends up holding on to more of that heat. All right, so this is believed to be causing the Earth to warm up. All right, so you guys have hopefully heard of this before. This process of the Earth warming up due to an increase in the greenhouse gases is called global warming. Okay, so how are we increasing the amount of carbon dioxide in the air? There's two major ways we're doing this. One is called deforestation. All right, essentially that's where lots of plant carbon, all right, such as in the form of wood, is cut down. All right, and when people cut down large forests, you got to do something with the wood. So either it's going to decompose or you're going to burn it. Either way, that's going to give off lots of carbon dioxide. All right, CO2. All right, the other is through burning of what you call fossil fuels. All right, fossil fuels are short term for coal and oil. And what this does is it takes lots of carbon that used to be underground when it was coal or oil, and when it's burned, it gives off carbon dioxide to the atmosphere. All right, so essentially this is why a lot of recent attention has been placed into what's called renewable energy sources such as solar and wind. All right, and the reason for that is it's a way for us to get energy without creating carbon dioxide that we put into the atmosphere. All right, another way to get power without giving off carbon dioxide is nuclear power. All right, but the problem with nuclear power, and nuclear is Nuclear, all right, is that it also has some environmental dangers. All right, if you're not very careful with a nuclear power plant, some bad things can happen, and it generates types of waste that are kind of hard to deal with.